Well, Cloud Build succeeded. We have a delivery pipeline made up of 3 environments. Now we can promote to the staging environment. Let's do it again in production environment. Hit the approve button. Done. The application is really in production and we have created in few minutes a continuous integration, continuous delivery pipeline using Google Cloud Build and Google Cloud Deploy. Hi, my name is Fabio Formosa. I'm a software architect and welcome to my channel. Cloud Build and Cloud Deploy are 2 fully managed services provided by Google Cloud Platform, and they are designed for fulfilling the continuous integration and continuous delivery. Why 2 services instead of only 1? Because Google has thought to split the continuous integration from the continuous delivery into different services. In this video, I'll be showing you how to build and deploy a web application into a Kubernetes cluster running on Google Cloud Platform and creating from scratch a pipeline based on Cloud Build and Cloud Deploy. Let me go back at the home. Here we come. To build and deploy an application, we need at least an application and a cluster. Regarding the cluster, we will be creating it from scratch using Terraform scripts. About the application, I'm the maintainer of an open source project which is called Quartz Manager, which is a Java library built around the popular Java library Quartz Scheduler. Through Quartz Manager, we can create and manage scheduled jobs, and we can do it through a UI and APIs. Let's start creating a Kubernetes cluster from scratch, and let's do it in an infrastructure as code fashion. I create a bunch of Terraform files, initially blank, and we start from them. Okay, now let's look for a Terraform module to create the cluster in Google Cloud Platform. Here we are. I don't want to reinvent the wheel, so let's open an example. This one, private zonal with networking. Let's open it in GitHub. I open the main TF file and I copy and paste. Okay, we have a module to create a new network with a subnet and a secondary range to allocate IP addresses to pods. The subnet, and here the module to create a new cluster based on a single zone. Let's change it a little bit. Let's make it public. We create the service account. We grant the registry access. We disable the horizontal pod auto scaling. And we remove the default node pool. So let's create a custom node pool. We remove also master authorized networks. That's it. I added a variable to define the machine type of the node pool. Start with a couple of nodes in a single zone And I added another variable to define the name of the service account will be associated to the nodes of the cluster. And this is the name of the service account I specified. I can type now Terraform plan. Let's take a look at the execution plan provided by Terraform. Okay, it's going to create a subnet, a cluster primary with the network, well, the execution plan is okay. Let's proceed to apply. Terraform will take some minutes to complete the cluster creation. Finally, the cluster is done. We can check it opening Google Console and reaching the Kubernetes cluster route. Yes, we have our cluster with 2 nodes. So we have a default node pool with 2 nodes of type E2 small, exactly like we want. Once created a cluster, we can move to the second stage, which is the containerization of an application. Actually, we could use a Docker image already available in whatever public registry, but as I said earlier, I'm a maintainer of open source project and I would like to base this video on that project. The project is called Quartz Manager, which is a Java library can be imported in Java projects. Despite the fact that it is a library, inside the project there is a web application that imports the library itself, and as a maintainer I use it for demo and manual tests. We can launch it locally and open it in a browser. We can see it in action. So here we can create a new trigger. Repeat interval in milliseconds to 2 seconds for 100 times. We submit it and we start the scheduler and we get the logs, the outcome of the scheduled job, which is for this example a simple hello world. And we can stop it, we can reschedule the job and resubmit it, making it faster. Let's resume the scheduler and yeah, we get an execution for each second. Okay folks, let's containerize this application. The Docker file is common enough. It's a multi-stage Docker file, the first stage and the second stage. In the first phase, we build the application to get a Java executable. As you can see, it's a Maven project. I run the build command with the profile webjar, which is a custom Maven profile that I set up that builds the front end as well. It creates a webjar for the front end that can be included in the web app. The web app is a Spring Boot application, so we will get at the end an executable jar. Let's try if the Docker file we have just written is correct. Let's build it. Well, the Docker build successfully completed. Let's try to run locally a Docker container from the Docker image we have just built. Yeah, it starts. Fine. Finally, we have a cluster and a containerized application. We can proceed instrumenting our CI/CD pipeline based on cloud build and cloud deploy. As any modern CI/CD platform, we have to write the pipeline in the form of a text file or a YAML file and push it within the repository. On the platform, we have to create what is called, for example, in Jenkins is called Jenkins job. In Google Cloud Build is called trigger. So now we create a cloudbuild.yaml file. This file is required by Google Cloud Build, and through this file we are going to define our pipeline. A cloudbuild.yaml file is made up of steps. Each step is executed in a container, and in the attribute name we can specify the name of the container where the step will be executed. We define a CI/CD pipeline made up of two steps. The first one is based on Google Cloud Build, is to build and push a Docker image, and we do it through the library scaffold. We will do it later. The second step is based on Google Cloud Deploy and is for to deploy the Docker image we have built into a Kubernetes cluster. Let's focus on the first step. The command we run is scaffold build. We run it in a Docker image based on scaffold library. We say to scaffold that we are interested in to push the Docker image built in a Docker registry. The Docker registry is a Google artifact registry, and here we pass the reference of Google artifact registry. The output of scaffold library build is a JSON. We specify the name in the file output parameter. Before scaffold build, we do some replacement of some placeholders we have. Scaffold library requires that a scaffold.yaml file is provided. In this file we can specify where scaffold can find the Docker file, the name of the Docker image we are going to build, and the Docker image version. About the version we can put a string literal, a placeholder, replace it in the cloudbuild.yaml with a set command, and we can replace it with a short version of the commit hash. Getting back to the cloudbuild.yaml file, as we said earlier, the second step of the CI/CD pipeline is for deploying in a Kubernetes cluster the Docker image we have just built at the first step. The second step is executed in a container based on Cloud SDK provided by Google. Within the container we have the availability of gcloud command line, and we use gcloud deploy to interact with Google Cloud Deploy service. Initially we apply a couple of files. One is pipeline.yaml, the second one is dev.yaml. Pipeline.yaml is to describe what Google calls delivery pipeline, which is a pipeline of environments. This pipeline is different from the CI/CD pipeline. The CI/CD pipeline is described in the cloudbuild.yaml, and it is to describe how we build the Docker image and how we deploy the Docker image in a Kubernetes cluster. Instead, the delivery pipeline is to describe the environments we deal with. In this video we will create 3 environments: the dev environment, staging environment, and the final environment, which is of course the production environment. Initially we are going to define only the dev environment. Now we have to create a couple of files, pipeline.yaml and dev.yaml. At the end, the last command is Google deploy release. We create a release in Google Cloud Deploy. We name it Quartz Manager Pipeline. We add a description and an annotations in a way that we correlate the hash of the commit. We pass to Cloud Deploy the JSON file generated by the first step. This is the way the Cloud Build step and the Cloud Deploy step are linked together. This is the pipeline.yaml. We are going to define a delivery pipeline for Google Cloud Deploy. We have given as name Quartz Manager Pipeline, and the same name we have to refer to here in the cloudbuild.yaml. Here we are going to define, which is made up of a series of environments. The first environment we will create is a dev environment. This is how we define a dev environment. The kind is target. This name must be the same to this one. And in the dev environment we have to declare where the cluster is placed. And this is the cluster we have just created through the Terraform scripts. For sure, you have noticed that we have written a couple of files in the form of a Kubernetes manifest, this one and this one, to define the dev environment and the delivery pipeline. That doesn't mean that these manifests are executed against our cluster, but this is the Google syntax. I suppose that they need these manifests because they run them internally in a Kubernetes cluster, but that's okay, it's just a matter of take it as an assumption. Let's open the Google Cloud Console and let's reach out Cloud Build. Before creating the first trigger, we have to connect to a repository. In my case, the repository is hosted in GitHub. There is an authentication process based on OAuth 2 protocol. I already granted Google to access to my repo in GitHub. I select the repo and now I can create the first trigger. We define a name, we select a region where the pipeline will run, a repository event which triggers the build, we leave push to a branch, and we say to Google that the pipeline is described in a Google Cloud Build YAML, and we specify the location. The service account is mandatory. We select the default service account Google has just created for us. So the CICD pipeline will run with this service account. So now we have to push a commit to let the trigger start. Google Cloud Build has successfully built the image. Let's check it opening Google Artifact Registry. We should find a container image called Quartz Manager Standalone. Yeah, a couple of minutes ago we pushed a new Docker image and this is the tag 9807. This tag should meet the commit hash. Let's check it. Yeah, it's the same of the latest commit. So now let's open Google Cloud Deploy. We have a Quartz Manager pipeline, delivery pipeline. Let's open it. A couple of minutes ago we had a new release. The release succeeded. And a minute ago the dev environment has been updated. Let's open the cluster. Let's open the workloads. And yeah, we have a Quartz Manager standalone web application running. So the deploy succeeded. As we can notice, the description of the release match the description of the latest commit we pushed. So we can prove the same, open Q9s. And yes, we have a Quartz Manager standalone running. That's it, we have just deployed our web application in the dev environment. Summarizing, we have created a couple of files for cloudbuild.yaml with two steps, the first one and second one. One for building and the second one for deploying. They both rely on scaffold library, so we have created another file called skaffold.yaml. Cloud deploy requires also a pipeline.yaml and a dev.yaml file. The pipeline is the description of a serial pipeline at this moment made up of one only environment called dev. And so we provided the description of the dev environment in this file, and we referred the GKE cluster we created earlier. Now we can emulate having more than one environment. We can emulate, for example, having a staging environment and a production environment, of course. To minimize the cost, I can't create 3 clusters, how I would do in reality. So let's create 3 environments in the same clusters, simply creating different Kubernetes namespaces. In the meanwhile, we have to add a couple of nodes to the cluster. So let's open the Terraform project and we add a couple of nodes. Let's apply the script. The other 2 nodes has been added. Okay, well, Cloud Build succeeded to release, and let's open Cloud Deploy now. Yeah, now we can see that we have a delivery pipeline made up of 3 environments in addition to the dev environment. Yeah, a release successfully deployed the latest commit in the dev environment, and we can see that the description of the release is exactly the same commit message of the latest commit. Okay, now we can promote the web application from the dev environment to the staging environment. Let's click on promote and we create a request of promotion. creating the request, we can look at the manifest diff. Let's promote. Okay, now we can see that there is a pending request of promotion. A user which has an approval permission can review the request of promotion. Again, he or she can take a look of the manifest diff, and at the end he or she can approve the promotion. The staging environment is upgrading. Well, our web application has been successfully promoted in staging environment. Let's do it again to promote it in production environment. Let's create a request of promotion. Again, another user which has the permission to review and approve the request can review it. He or she can take a look at the manifest diff, and at the end he or she can hit the approve button. Our web application is rolling out in the production environment now. Let's wait a couple of minutes. That's it, and finally our web app application Quartz Manager has been successfully rolled out in production. Let's open the Kubernetes cluster. Workloads. And yeah, as you can see, we have an instance of Quartz Manager standalone in each of all Kubernetes namespaces we created. One for emulating the dev environment, the other one for emulating the staging environment, and the last one for emulating the production environment in the same cluster. We have not created a Kubernetes ingress, so we can reach publicly the web application, but what we can do is opening a port forward against Quartz Manager prod namespace. I open a port forward using as local port 8080, localhost 8080, manager index UI, and that's it. I'm able to reach the production instance of Quartz Manager. I can log in, and yeah, that's it. We are quite at the end of this video. Let me make a couple of final considerations. So now the question could be why to use Cloud Build and Cloud Deploy. In my opinion, there are 3 points it's worth to mention. If you deploy your web application in a Google Kubernetes engine or Cloud Run, Cloud Build and Cloud Deploy are natively integrated with these services and other ones, for example, Google Artifact Registry. As you can notice, we didn't specify any credentials in our CICD pipeline to push the Docker image in a Google Artifact Registry or to store a JSON file in a Google storage bucket. If you can't afford the cost and the burden to maintain a self-managed instance of Jenkins, for example, you can adopt this solution based on Cloud Build and Cloud Deploy, because it is a pay-as-you-go solution. If you are afraid of a cloud provider lock-in, we can say that this solution is a straightforward solution. All pipeline stages are executed in a container, so it's the same model followed by GitHub Actions or Bitbucket pipelines and others. Furthermore, the scaffold library we have used in Cloud Build and Cloud Deploy is an open source library that can be used even out of Cloud Build and Cloud Deploy. Well, you have reached this point. Now you can give your feedback with a like, or you can write your thoughts in the comments. You can share your experience with Cloud Build and Cloud Deploy or similar CI/CD platforms. That's it. Have your bits well aligned and see you at the next video.